Continuing on from our measures of central tendency, we also have measures of dispersion. As you can tell, measures of dispersion tell us how far a data set is going to be dispersed. And we're going to look at a couple examples of non-dispersed data and dispersed data. Dispersion can take on a couple of different forms. We're going to talk basically about the range, the variance, and the standard deviation. And once again, these are also going to be global descriptive metrics. So these will be global descriptive metrics that describe the entire data set. So I'm looking at here under my chart properties. I just went to right mouse click under median age, display statistics, and you can see these calculated right here. And so I've got the mean, median. Now what we're going to look at today is the standard deviation. And you can see the standard deviation is 4.5. And then we'll talk about how we can calculate the variance. And then we also have the max and the min. And so the range is just going to be the max minus the min. So the max minus the min. It'll always be a positive number. And it's essentially the absolute value of the difference between the two, because absolute values are always going to be positive. So to calculate, it's going to be 49.5 minus 25.9, and it's only going to be a single number. So if I ask for the range, don't put 25.9-49.5. This is a measure of dispersion. And then we have the standard deviation. And so we looked at in class the normal distribution, and we saw that standard deviation tells us about 67-68% of all data is going to kind of be within these numbers right here. You see the standard deviation. You can see one standard deviation above the mean here is about 44.78. One standard deviation below the mean is going to be about 35.34 or whatever we're looking at here. So most of the data is going to be here in a normal distribution. We kind of throw everything out the window when we're dealing with kind of non-normalized data, And these standard deviations are going to be the same. So you can see between the high and the low, we're going up 2.5, maybe 3 standard deviations. And so when we calculate these in Excel, let's get a good idea as to what a right answer looks like and a wrong answer looks like we talked about with the weighted mean. And so we've got this example right here that we can go and hand calculate these. And so when we look at our z-score value, which is going to be the value minus the average divided by the standard deviation, we can kind of look these up or calculate these here. And for 40.8, I can do 40.8 for this particular county minus the mean divided by the standard deviation. And you can see it's going to be 0.3 divided by 4.5, which is barely above the that's going to be the z-score, which is going to be barely above our mean. And so we've got positive values for our z-scores, and we'll talk about that in a second as well. So like we did before, I'm going to type in the word variance. And so to calculate the variance, it's just going to be the value, whatever the value is going to be, minus the mean, and then we square it and then add it all up. Okay. So in essence here we've got the mean. So for this one it's going to be 28,447 minus the mean. We square and then we add it up to whatever it is for Bertie and Scotland and Richmond and Halifax and all these other things here. And so I can type in the word equals. I'm going to type in the word variance P for, and then once again, we're going to use this calculation here. So you can see this big number here. Okay, well that doesn't do too much for me. But now we've got standard deviation. Now we did, so we're going to look at the standard deviation. Equals STD, standard deviation P. And you can see there's different standard deviations. Some of these have been deprecated. All right, based on what? We're just going to look at this. This is the standard deviation, 7,657. And so everything within one standard deviation of income is going to be about 47, 48,000 down to 32, $33,000. About that. About those. And so you can see the variance and the standard deviation because I can calculate for different data sets. And just for the heck of it, I'll type in the word range, see if we can calculate it. So it equals, let me type in the word range. Well, I don't see anything here for range. But I did talk about the calculation. So equals max of what? Maximum of these. Make sure I got this calculation correct. Equals the max. I did something wrong here. All right, max. Minus the min. And so we can see the max minus the min. So if we were to add 35,232 to this number, we would get the max. So we have these here. And so we've got examples here of standard deviation. I calculated some things here for North Dakota, and I thought it was just kind of interesting because we've got some North Dakota data. We can see how much it varies here. And so just for the heck of it, I might type in equals S standard deviation. This number here. Go and calculate it. And you can see it's 7,263 versus North Carolina, 7,657. So what does that mean? It means the data, the incomes in North Carolina vary a lot more, or a little bit more from the mean versus that in North Dakota. So the variance is going to be a little bit, well, in this case, this is the standard deviation. And in looking at this, you can probably see the relationship between the standard deviation and the variance. The standard deviation is just going to be the square root of the variance. So I'd rather work with 7657 as opposed to 7657 squared, which is this big, ugly number here. So we've got these calculations right here, standard deviation. So we've got the variance, standard deviation range. We're looking at another data set right here where the standard deviation is a little bit different. And then another example that we have here is that I've got some football wins for the Eagles versus the Bison, and you can see the number of wins here throughout the last 20 years. You can see the number of wins here. So we got 2, 8, 9, 9, 3, 6. But real quickly, I'm going to calculate the mean for these. So I'm going to calculate equals the average. And now look what I'm going to do in this case here. And now I can drag these across, represent each row. And you can see the Eagles in column B, the Bison in column C have the same number of average wins each year. But if I were to look at the standard deviation equals ST deviation, for what, these numbers, these 20 numbers, standard deviation is 1.09 versus 3.17. And so this is a great example of data that has the same average but much different standard deviations, meaning that these data here in column C with the Bison, they range a lot more, they deviate a lot further from the mean versus the wins for the Eagles. So we got 5, 6, 5, 4, 7, 5, 6, 7, 4. They're fairly close to the mean, while there's much more wide-ranging data. We got 2, 0, 11, 7, 6, 8. So you can see these up and down that deviate far from the mean are going to manifest themselves through these different standard deviations. So this is what standard deviation means. How variable is your data? The last thing we'll look at is, well, we want to calculate a z-score because this is all good and well. And so we're going to do another column right here where we're going to look at the z-score. Now remember what the z-score represents. So the z-score tells us how far away it is from the mean. And remember the formula, the z-score is going to be equal to the value minus the average, all divided by the standard deviation. So the value minus the average, all divided by the standard deviation. So each county is going to have its own unique z-score. And so when it has its own unique z-score, this is what we call a local statistic as opposed to a global statistics, where that mean, median, range, standard deviation, average describe the entire data set, whether it's dispersion or central tendency, where that each county is going to be assigned or calculated a z-score based on how far away it is from the mean. And so we can calculate these. Now we can calculate these by hand. Okay, the formula, the z is equal to x minus x bar, which is the standard deviation. Calculate that, and then divide the whole thing by the standard deviation. Now let's calculate these for the column. And in class originally, I kind of encourage people to kind of hand calculate these, but we'll do these in Excel. Now what do I have here? What do I need? I need the standard deviation, and I need the mean. And so what I can do here is I can calculate equals, what's the value for Wake County? 63,000 minus, and I'm going to put this in parentheses because these need to be calculated first, minus what? The mean, all divided by the standard deviation. Now when I calculate this, we'll see what kind of number we get. So 2.99, I'm going to right mouse click and do format cells because it wants to treat it as a currency, and in this case it isn't. Because remember, z-scores are going to be unitless. Z-scores will be unitless. So when we do the value minus the mean, that's going to be in dollars, standard deviations in dollars, so that the units are going to cancel out essentially. Now the trick is, once I start kind of dragging down here, we're going to get some really ugly things right here, because what's happening? We want to move down the calculation, we want to move down with the median household income, but we want these mean and standard deviation to be the same thing here. We want them to be the same. Okay, we don't want to keep moving down as we do this calculation. So we want these to remain the same. And so a little trick we have here, we can actually type this number in, but one thing that I have here is I've got the little dollar sign. So that means that keep it consistent, okay? Basically it means freeze. I'm going to freeze it right here as well. So now I'm going to calculate it here. And then once again, Excel is kind of trying to be a little bit on the smart side and say, hey, this is really a currency, but it's not in that case. So now I'm going to drag it down. And since we sorted these in order, essentially what we're doing is we're going from the highest z-score, which is 2.99, just under 3, all the way down to about negative 1.61. And I can right mouse click and you can see I'll click on format cells. I don't want to have negative numbers right there like that, so I'll just put it like that. So it was putting the negative numbers in red all the way down to like negative 1.61. And now I can go back if I wanted to sort my data. Data sort. Well, this time I'm just going to sort by county from A to Z. And now I can see, all right, Alamance County is about 0.43 standard deviations above the mean. Alexander County is negative 0.11 standard deviations below the mean. And so Alexander County, I bet you, is going to be slightly below the mean, 40,848. So we have some really good calculations right here, really good calculations. And so now we're measuring local dispersion, so how far each of these counties are from the standard deviation, which is unitless. And so the advantage of this is that now I can compare this z-score for median household income to something like median age or percentage of people that own a vehicle, that we can start to combine these different units because these z-scores are going to be unitless. So we've got a real powerful tool right here. And you can see these numbers went from about negative 1.6, 1.7 all the way up to 3. So you can see these data, and when we did this measures for central tendency, they were skewed a little bit to the right because we had some of these high values with Wake and Chatham, and I think it was Union County as well. And so in this talk, summary is we looked at measures of dispersion, we looked at range, variance, standard deviation. We looked at ways that we could calculate some of these here with ArcGIS Pro. You can see it doesn't give you variance, but it's got standard deviation. So if we were to multiply the standard deviation times itself, we've got the variance right there. We also did this in Excel. We looked at an example of data that had the same mean but much different standard deviations, and we looked at another data set that had a lower standard deviation, which means it didn't vary as much from the mean as well. And then finally, we calculated a z-score, which is going to be a local statistic, which is going to be unique for each county, which measures the distance from the mean based on the standard deviation that we went through the trouble of calculating just now, as well as the mean that we calculated in a prior video.